This video is about bond enthalpies. So the keyword in the question gives us a reaction between methane reacting with oxygen to produce carbon dioxide and water vapor. And they tell us to use section 11 from the data booklet, as well as give our answer in the form of energy in kilojoules. And the concept is to calculate enthalpy of reaction using average bond enthalpy. So here we have an example of a reaction, carbon reacting with oxygen to produce carbon dioxide. And remember to always balance your chemical equation. And then we're going to use this formula right here. So this formula gives us that the enthalpy of reaction, delta H, equals to the total of the average bond enthalpy of all the bonds that are broken. And that means it's the reactants. And minus the total of the average bond enthalpy of the bonds formed. And that is the products. This makes sense because we need to put in energy. So there is a positive amount of energy to be able to break the bonds. And since the bonds are broken, it then can form new bonds. And once new bonds are formed, it releases energy. So there is a negative amount of energy. So that's why we can see the sign before it's positive for the bonds broken and negative for the bonds formed. So we can set this up by first drawing the Lewis structure of our chemical reaction. So we have something that looks like this. And then we can use our section 11 to calculate the bond enthalpy. So carbon is bonded to nothing, so it's 0. O double bond to O is right here. It's 4, 9, 8. And then there's 2 bonds of O double bond to C. So that's right here, and that's 8O. And then we can simply plug these values in our equation, and we would have something looking like this. And punch that in your calculator, and you will have the result of 1,110 kilojoules. So now that we understand the concept, we can go back to the question and apply the same method. So we first need to write the chemical reaction of what we know from the question, which is methane reacting with oxygen to produce carbon dioxide and water vapor. And then we can move on to balance this equation, and we would have something looking like this. And then it would be easier to draw out the Lewis structure, and we would have something looking like this. And we can simplify this to the number of individual bonds. So we would have something that looks like this. And remember, the individual bonds need to be multiplied by its coefficient as well. And everything on the left side, the reactants, is positive, and everything on the right side, the products, is negative. And then we can plug in the individual values that could be found in section 11 right here. And we would have these values right here, and plug that in the calculator. We would have the answer of the bond enthalpy of the enthalpy of reaction is equal to negative 808 kilojoules. And that's our final answer.